Hi everyone, this is Edward from STEM. Today we are going to be looking at A-level physics, and our topic for today is motion, uniform acceleration. And our objectives, by the end of the video, you should be able to define speed, velocity, and acceleration. Secondly, you should be able to apply equations of motion for uniform acceleration. And lastly, you should be able to apply equations of motion to projectile motion. But before we continue, you can support our channel by subscribing to the channel, liking, and sharing the video. And don't forget to turn on your notification bell so that you get to be notified whenever a new video like this is dropped. So let's get started. So let's start with the basic concept. And the first concept I'm going to look at is distance and displacement. Okay, we're going to look at the difference between distance and displacement. Now, distance basically is how far an object moves. Okay, how far an object moves. Let's, for example, we'll say a car. Okay, a car moves 50 kilometers. Okay, now the car moves a distance of 50 kilometers. That is a distance. Now we don't know where the car is going to, right? We don't know where the car is heading to. It just moved 50 kilometers. Now displacement, on the other hand, is a distance that has a direction. Okay, that is distance an object or a body moves in reference to a particular direction. Let's say this car now moves. The car moves 50 kilometers towards east. Now this is the direction, right? The difference between the distance and displacement is that distance is a scalar quantity. A scalar quantity. Now a scalar quantity is a quantity that has just magnitude. Magnitude, but no direction. Right? Why? Displacement, on the other hand, is a vector quantity. A vector quantity has both magnitude and direction. Okay, so that is the difference between distance and displacement. And the SI units of distance and displacement are the same. They are both measured in meter. They are both measured in meter. Okay, so I hope that's clear. So that's the first basic concept. Another concept we are going to look at is speed and velocity. Speed and velocity. So now speed basically is the distance moved divided by the time taken. Right? That is speed. While velocity, on the other hand, is equal to the rate of change of displacement. Okay, change of displacement divided by the time taken. Now, just as we have the difference between distance and displacement, Now, speed is a scalar quantity, all right? It's a scalar quantity, while velocity is a vector quantity. Okay, velocity is a vector quantity. Okay, so now both speed and velocity are both measured in meter per second. That is the SI unit. They are measured in meter per second. Now I'm going to describe the difference between speed and velocity. Now, the speed of a body at a particular instant is equal to its velocity at that particular instant. But that is not the case for average speed and average velocity. So the average speed is not equal to average velocity at that particular instant. Now I'll explain why. Now we know that average speed is the total distance divided by the total time taken. Okay, divided by the total time taken. Alright, but average velocity is equal to the total displacement divided by the total time taken. Right? Now let's look at this example. Let's say we have a car that moves 5 meters towards east. Okay, a car moves 5 meters towards east in 2 seconds. Okay, in 2 seconds. And then the car decided to turn back and move 5 meters towards west, also in 2 seconds. Now, what will be the average speed and average velocity of this car? Let's start with the average speed. The average speed is equal to, like we said here, the total distance divided by the total time taken. Right? Now, the total distance will be 5 plus 5, that is 10. That will be 5 plus 5, 10, divided by the total time will be 2 plus 2, which is 4. So we have 10 over 4, and that will give us 2.5 meter per second. Right? And let's look at the average velocity. The average velocity in this case will be total displacement divided by the total time, and the displacement here will be 5 minus 5. Okay, so displacement will be 5 minus 5 divided by the time taken, which is 4, and that will give us 0 divided by 4, and that is 0 meter per second. As you can see in this case, the average speed is not equal to the average velocity. I hope that makes sense. So let's look at the last basic concept, which is acceleration. Acceleration. Now, acceleration basically is velocity divided by time, right? And the SI unit of acceleration is meter per second square. You can write it this way, or you can write it this way, meter per second square. They are both the same thing. And acceleration is a vector quantity Okay, is a vector quantities because velocity is a vector quantity. All right. Now let's look at average acceleration. Now this is the total change in velocity, total change in velocity divided by the total time taken. All right, so that is average acceleration. Of course, the same SI unit, meter per second square. So they're basically the same thing as just acceleration. Just that when you're considering the average of acceleration of a body, you pay attention to the change in velocity. Okay, so the total change in velocity divided by the total time, that will give us the average acceleration of that particular body or object. I hope that makes sense. Now we are going to look at the four equation of motion. Okay, we are going to look at the equations of motion. So now let's look at the equations of motion. For uniform acceleration. Okay, and the first equation of motion is V is equals to U plus AT. And the second one, V square is equal to U square plus 2AS. The third one, S equal to UT plus half AT square. And the last one is number 4, S is equal to half, S is equal to half bracket U plus V bracket close T. Okay, so these are the four equations of motion. Now let's look at the parameters here. Okay, let's define the parameters here. V is known as the let's start with U. U is initial velocity. V is final velocity. A is the acceleration. Okay, T is the time. Ys is displacement. Okay, displacement from the starting point. Okay, so these are the four equations of motion. Now we are going to look at the application of this equation of motion. Now there are a couple of things you need to take note of before you start applying the equations of motion. All right, now these parameters that we have, the initial velocity, the final velocity, the acceleration, and displacement as well. Displacement. Now these parameters can have either negative or positive value. Okay, and these values depend on the position of the parameters. If a displacement is positive, okay, it means that the displacement is above the starting point. All right, now let's look at this now. Let's say a ball move, okay, 50, let's say 50 meters towards east, okay, 50 meters towards east, and then moves, sorry, 50 meters, and then moves 20 meters towards west, 20 meters. All right, now the displacement here will be 50 minus 20, which is 30 meters. As you can see, in this case, the value of displacement is positive. Okay, now it is above the starting point. Okay, now let's look at a scenario whereby the ball moves 50 meter. Let's say the ball moves 50 meters towards east, and then moves 70 meters towards west. 70 meters. Right? Now, what will be the displacement at this point? Now, displacement will be 50 minus 70, and that will give us 20 minus 20 meters. As you can see, the value of the displacement here is negative because it is below the starting point. And in this case, now this is horizontal, right? But in a vertical instance, we have above to be positive and below to be negative. I hope that makes sense. Now, so same thing is also applicable to the initial velocity and the final velocity. The positive and negative values of the velocities refers to its direction. All right. Now let's look at initial and final velocity, u and v. Now let's say, for instance, if you throw a ball up, right? Now, if the initial velocity of that ball when it's going up is positive, if the initial velocity is positive, as the ball is coming down, right, the final velocity v will be negative. I hope that makes sense. So it's basically depends on the direction. Now, acceleration, when you have a negative acceleration, when acceleration is negative, it means that the object or the car or the body is coming to a stop. Okay, it means it's coming to a stop. So that is when you have a negative acceleration, and it also refers to as retardation. Okay, the negative acceleration is referred to as retardation. Okay, which is minus a. All right, so I hope that's clear. All right, so let's look at this example. But before we continue with the example, I would like to drop tips on how to approach problem using equations of motion, and these tips will help you to solve any problem that involve equations of motion. Right? And so the first thing you are going to look at is you have to check if the body is moving with a constant acceleration. Okay, check if the body is moving with a constant acceleration. That's the first thing you have to check. And the second thing you have to check is the second thing you have to do is you have to write down the parameters that you have. Okay, write down the parameter. Let's say you have your initial velocity, if you have the final velocity, if you have your acceleration, if you have your displacement, and also your time. So that is the second thing you're going to do, is to write down these parameters down. So this basically is like a step, okay, that will help you to achieve your goals of solving that particular problem. And the third thing you're going to do is to check from these parameters here which of them you are asked to look for, or which of them you are looking for. And maybe if you're asked to find acceleration, or if you're asked to find time, or if you're asked to find displacement or whatever. So you have to take note of that as well. Then after that, you then decide which of the equation is suitable for what you are looking for. Okay, decide the equation suitable. Okay, decide the equation you're going to use. All right, then after that, you then substitute the values. Okay, then substitute the values into the equation. All right, once you've done that, then all you do, you check your answer, you calculate and check your answers to make sure that it makes sense. Okay, I hope that is understood. Let's look at this question. Let's solve this question together. So the question says, a particle is moving in a straight line with constant acceleration. Now, take note, constant acceleration. It passes point P with speed 2 meters per second. Now, note here it says that it passes point P with speed 2 meters per second. So it means it already has a speed before it passed the point P, right? So which means our initial speed, this speed is our initial speed. So from here we have our initial speed u to be 2 meters per second. Okay, then it said 10 seconds later, that is our time. Now we have our time to be 10 seconds. Now 10 seconds later, it passes point Q. The distance between P and Q is 40 meters. Okay, so our distance, our S, is 40 meters. Okay, now the question says find the speed of the particles as it passes point Q. Find the speed of the particle as it passes point Q. Now, it means that you have to find the final velocity. Okay. Now, did you see what I did? So that is the step that you are going to follow before you're able to answer questions correctly, right? And besides, following this step as well gives you marks, during your examination. Okay, but this step alone can give you like 1 or 2 marks. All right, so it's very, very important. All right, now so we have to find the final velocity. We have our u, initial velocity, we have time, we have distance, and we have to find the final velocity. So which equation is suitable for this question? Which of the equations of motion is suitable for this question? Now, there is one equation that consists of initial velocity, time, distance, and velocity. Okay, and the equation is S is equal to 1/2 bracket u plus v bracket t, close bracket t. Okay, so here we are looking for the final velocity v. Now what you need to do is to make this v your subject of formula. You make the v here the subject of formula. Okay, so this S is the same as u plus v divided by 2, right? Then bracket t, right? So you have that S will be equal to ut plus vt divided by 2. If you cross multiply, you have 2s equal to ut plus vt, right? You're looking for v, So Vt will be equal to 2s. Okay, so you collect like terms. This ut will move towards this side. It's positive, so it becomes negative, minus ut. Therefore, our v will be equal to, you divide both sides by t, v will be equal to 2s minus ut divided by t. So this is the equation we are going to use to calculate our final velocity. Alright, so that is our final velocity equation. So let's just substitute the values into this equation. Our v will be equal to 2 bracket, what's our s? 40. Our s here is 40 meters, minus, what is our u? The initial velocity, which is 2 meters per second. So we have 2 bracket, what is our time? 10 seconds, 10 divided by our time is 10. So you calculate 2 times 40 is 80 minus 2 times 10, 20 divided by 10. 80 minus 20, that gives us 60. Now 60 divided by 10, that will give us 6. And we are looking for velocities, right? So our answer here is 6 meters per second. I hope that makes sense. Now, if you find the previous method challenging, you can use this method instead. Okay. First of all, you write down your parameters. You have that your u, okay, your u is equal to 2 meters per second. That's your initial velocity. What else do we have here? We have that time t is equal to 10 seconds, and we have that s is equal to 40 meters, and you have to find the final velocity v. The equation we are going to use is s is equal to 1/2 half bracket u plus v close bracket t. Right? So now what you can do here is you can substitute in the value directly into this equation. Okay, so our s is 40, so we have 40 is equal to half open bracket u is 2 plus v close bracket, our t time is 10. Okay, so you can open the bracket by multiplying the values outside the bracket with those inside the bracket, right? So half times 2 will give you 1, right? And 1 times 10 will give you 10. So 40 is equal to half times 2 will give you 1, then that 1 times 10 will give us 10. So we have 10, right? Plus half times v over 2, right? V over 2 times 10, so v over 2 times 10, 10 divided by 2, we have 5. That will give us 5v. Okay, so 10 plus 5v. So collect like terms. This 10 here will move to this side. Okay, it's positive, so as it's crossing, it becomes negative. Our 5v will be equal to 40 minus 10, and 5v is equal to 30. V therefore equals to 30 over 5, and that is 6 meters per second. I hope that is clear. So you can choose any of the method you want to use. Let's take a look at another work example. It says a particle is moving in a straight line with constant acceleration 0.2 meters per second. After it has moved a total of 20 meters, its speed is 8 meters per second. Find its initial speed. I want you to pause the video and give it a try. So let's get started. Now, solution. First thing we are going to do according to our steps is to write down the parameters. We have that our acceleration, constant acceleration, is 0.2 meters per second square. And after it has moved a total of 20 meters, that is our distance, is 20 meters. Its speed is 8 meters per second. Find its initial speed. So since you are looking for initial speed, which is u, our final speed therefore is 8 meters per second. Okay, now the next thing to do is look for the equation that is suitable for this question. Okay, the equation that consists of all these parameters we have here. Okay, so and that will be v square is equal to u square plus 2as. Right, now the next step is to put the values into the equation. Our v square, that our v is 8, we have 8 square is equal to, we are looking for u, we don't know that, u square plus 2 bracket, what is our a, 0.2 bracket, what is our s, distance, this is 20 meters. Okay, bracket close. Now let's evaluate this. 8 square is 64 is equal to u square plus 2 multiplied by 0.2 multiplied by 20 will give us 8. So collect like terms, u square will be equal to 64 minus 8. And what is 64 minus 8? That is 56. So u square will be equal to 56. Now to remove this square, you have to square root both sides. So we square root of this, of u square, and square root of 56. We square root to cancel the square. You have u equals to square root of 56, and that will give us 7.48 meter per second. Don't forget the unit, meter per second. I hope that is clear. Let's look at another work example. I want you to pause the video and give it a try. Now it says a particle starts from rest and moves with constant acceleration 0.5 meter per second square in a straight line. Find the time it takes to travel a distance of 8 meters. So following the steps, solution, we write down our parameters. We have constant acceleration of 0.5 meter per second square. So a is equal to 0.5 meter per second square. And then we have to find the time taken. So we are looking for t, we don't know our t, but we have a distance of 8 meters. So our distance s is 8 meters. We have acceleration, we have time, we have distance. So which of the equation will be suitable for this to answer this question? And now let's look at this question properly. It says a particle starts from rest. So whenever you see any statement that says from rest, it means that the initial velocity is 0, right? So we have to add our another parameters here, that u is equal to 0 meter per second, because it starts from rest, right? So now, which of the equation will be suitable for this to answer this question? So we're going to use s is equal to ut plus half at square. Okay, now let's put our values into the equation. We're going to have that s is 8 is equal to, our u is 0, right? 0, okay, multiplied by time, t plus half, our a is 0 0.5, and you're looking for t square. So anything multiplied by 0 is 0, so this will be equal to 0. So 8 will be equal to 0 plus 1/2 times half. So that will give us 0.25 t square. Alright, so collect the like terms. This 0 will come over here, so we're going to have 0.25 t square is equal to 8 minus 0. So 0.25 t square is equal to 8 basically. And you're looking for t, divide both sides by 0.25. So you're going to have, so let's continue from here. Let's continue from up here. So you're going to have t square will be equal to 8 divided by 0.25. So 8 divided by 0.25 will give us 32. So therefore t will be equal to square root of 32. Alright, so that will be square root of 32 will give us 5.65. So we're having t to be equal to 5.6568. So let's leave our answer in 3 significant figure. That will give us 5.66 seconds. I hope that's clear.